All right, we are on linear functions practice. This is using linear functions. We're going to write the equation based on some given information, based on the graph. We're going to find slope given information, find slope given a table, and finally write an equation given a table. Okay, so remember, a linear function follows y equals mx plus b, where m is your slope, which is rise over run. Rise is your y values, run is your x values, and b is your y, is your y, I think I'm writing too high up. Okay, is your y-intercept. So where either x equals 0 or where your line crosses the y-axis. Okay, that's the one going up and down. Okay, so for this first one, write the equation of the line with the given slope and y-intercept. Okay, well, slope is -3, that's my m value, and my y-intercept is 7, that's my b value. So I'm going to plug it in. M equals -3, b equals 7. So y equals -3x plus 7. Number 2, if my slope is 1/4 and the y-intercept is -5. Slope is m is 1/4, y-intercept is -5, that's my b value, I plug them in, y equals 1/4 x minus 5. For this next part, write an equation based on the graph. Remember, y equals mx plus b, so we need to first, either order, you need to find your y-intercept, you need to find your slope. Here's my y-intercept where I'm crossing the y-axis, or when x equals 0, this is my y-intercept. My y-intercept is -1. And then my slope, so I've got these 2 points identified on my graph. 1 point, 2 point, okay? Remember, rise over run. So how many did I go up? How many times did I go up? How many times did I go over? Well, from this purple point to the blue point, I went up 3, 1, 2, 3, and I went over to the right 5 times. Okay, so up is a +3, right is a +5. So my slope is 3/5. Notice my line is increasing, so my slope should be positive. And then my y-intercept, we said, was -1. I plugged those values into the equation. Altogether, y equals 3/5 x minus 1. For number 4, same thing. Slope, y-intercept. Plug it into y equals mx plus b. So my y-intercept, right there, looks like at 2. So my b value is going to be 2. And then I found the other, I don't know the specific word, but I like to call it a nice point, where the line crosses on a grid line. I can see, okay, this is an identifiable spot that I can put my dot, okay? So again, rise over run. I went down 2 from the top purple dot to the bottom purple dot. I went down 2 little boxes, and then I went to the right 3. Well, down 2 is negative, because I'm going down, -2. To the right is still positive, so my slope is -2/3. Notice that my line is decreasing, so I should have a negative slope, and I do, -2/3. And then I plug it into my equation, y equals mx plus b. M is -2/3, b, or my y-intercept, is 2. Number 5, they drew on dots for us, thankfully. I didn't have to find nice points. But here's my y-intercept at -3. I know this graph is kind of grainy and blurry, but we are at -3. And then my slope, how did I get from this bottom blue point, my y-intercept, up to the top blue point, or from the top blue point down to the blue point? Either way, totally fine. It's 100% up to you. I usually like to start at the top and go down. It just is easier for me, but you could also go from the bottom point to the top point, rise over run. So going from the bottom point, let's try something new. We'll go from the bottom point to the top point. I went up 6 units and I went to the left 2. Okay, so up 6 is positive 6, left 2 is a negative 2. If you had done it from the top to the bottom point, you would have gone down 6 and to the right 2. Down 6 is a negative 6, and to the right 2 is a positive 2. You still would have gotten the same exact slope. Your negative just would have been on the top instead of the bottom, but in the end, it doesn't matter. 6 divided by negative 2 is negative 3. Please reduce your fractions. So your slope is negative 3, and your y-intercept is also negative 3. So y equals negative 3x minus 3. For number 6, I have my y-intercept. I don't have any other points drawn on here, so I'm going to go down until I find a nice point, one where the line or my function crosses on a grid point, if that makes sense. And then there's my y-intercept at 3. I will calculate rise over run to find my slope. From the top point to the lower point, I went down 5 and I went left 3. Okay, so down 5, minus 5. Left 3, also a minus 3. Negative over a negative is a positive. Just like a negative times a negative is positive, a negative divided by a negative is also a positive. If you don't believe me, go ahead and type it into your calculator real quick. Should get a positive answer. So my slope is 5/3. It does not reduce, so I don't need to do anything there. I just need to plug it into my equation. So y equals 5/3 x plus 3. And one other thing about slopes, please do not write them as a decimal. They should be a fraction because it's rise over run. If you have a decimal, it's very difficult to graph. Not impossible to graph, but it's very difficult. It's so much easier to graph when it's in a fraction because you just go up and over however many numbers you have. Next part, find the slope and show your work. Okay, so we have y equals 4x plus 5. Well, m is slope. Pretty easy to identify. My slope is 4. Okay, it's just right in the equation. This next one, I'm given 2 different points. So if I were to graph them, I could just go rise over run. Unfortunately, it's not graphed, so I do need the slope equation. And it's the difference of the y's over the difference of the x's, okay? You might have it memorized as y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1. I've seen a variety of different methods being taught. It does not matter. They all mean the same thing. So I like to say difference of the y's over difference of the x's. Sometimes that's a little bit easier for students to remember. If you need to, if you're not too confident in your work, I would label the points. So this first one I labeled x1 and y1. The second set of points I labeled as x2, y2. It doesn't matter which one you do. You could have done the first one as x2, y2, and the second one x1, y1. Totally doesn't matter. It's just labeling the points so you can plug them into your formula so you can solve. So I'm going to plug in the 2 y values, -8 minus -20. Minus a negative is a plus, so -8 plus 20, and then I'll plug in my y values, which is -3 and -12. Again, minus a negative is plus, so -3 plus 12, and then I just solve right across. -8 plus 20 is positive 12. Negative 3 plus 12 is a positive 9. 12 over 9 reduces to 4/3. So that's my slope, 4/3. Rise, I go up 4. Run, I go to the right 3. Very similar to number 9 here. I'm going to label my coordinates x1, y1, x2, y2 so that I can plug it into the formula. I'm not going to rewrite the formula. If you want to, you can, but I'm just going to plug in my y values. Okay, so 11 minus 0, plug in my x values, 17 minus 5, and then I just solve across. 11 minus 0 is 11, 17 minus 5 is 12. It does not reduce, so my slope is 11 over 12. Next part, given the table, find m. Show your work. Okay, rise over run, y's over the x's, difference of the y's over difference of the x's. So going with that, I'm going to find the difference between my x's. How did I get from one x to the next? So from -6 to -5, I added 1. -5 to -4, I added 1. -4 to -3, I added 1. -3 to -2, I again added 1. Brilliant. Okay, let's do the same thing for the y values. How did I get from 12 to 14 to 16 to 18 to 20? Well, I added 2. Okay, now it's difference of the y's over difference of the x's. The difference of the y's was +2. Difference of the x's was +1. So 2 over 1, which reduces to just 2. So my slope is 2 for that one. If you want to, it is 100% fine to leave it as a fraction. Some students prefer to leave it as 2 over 1 because then they know to go up to right 1. It is 100% up to you. Either one is perfectly acceptable in my class. This next one, number 11, I'm going to do the same thing. Difference of the x's, difference of the y's. How did I get from -14 to -12 to -10 to -8 to -6? I added 2 each time. Same thing for the y's. 3, 6, 9, 12, 15. What did I do? I added 3. So then I'm going to go y over x. So 3 over 2 is my slope. I want you to try number 12 on your own, okay? Number 13, we're going to do the same thing, except I want you to write the linear equation. So I want you to find slope and the y-intercept. So again, y equals mx plus b. You are plugging in m. You are plugging in b. So we're going to find slope just like we did in those previous 3 examples. Difference of the y's was +1. Difference of the x's was +2. So my slope is 2 over 1 or 2, either one. Either way, totally fine. Okay, now I need to find my y-intercept. And if you remember what I said, at the first thing I said pretty much about y-intercept is when x equals 0. So when x equals 0. Okay, unfortunately, we don't have x equaling 0, but I can just continue the pattern. I can add 1 to the x's, add 2 to the y's. Got -1. Do it one more time so I get to 0. X equals 0, y equals 24. So my y-intercept is going to be that 24. So I plugged in my slope. I like 2 as just a whole number. You could have it as a fraction, 2 over 1, up to you. X plus my y-intercept is 24. Same thing for the next one. How did I get from -14 to -12 to -10 to -8 to -6? I added 2. For the y's, 3, 6, 9, 12, 15, what did I do? I added 3. So my slope will be 3 halves, 3 over 2. I need to find when x equals 0. So I'm going to add 2 to the x's, add 3 to the y's. So -4, -2, and 0. Again, it equaled 24. This time the only difference was my slope was 3 halves, so 3 over 2x plus 24. And then I want you to try the last 2 on your own and submit them.